Well, hi, it's Tim the Tool Man here again today with another episode of Do It Yourself. And today we're going to talk about troubleshooting Christmas lights, mini lights in particular, and incandescent lights. There are a lot of people on the forum that have been asking questions, and I know there are a lot of people out there that are having trouble with this, and there are a lot of people that know absolutely nothing about troubleshooting these lights. So I have a few tips and tricks here today. I don't pretend to know everything there is to know about this, but hopefully we'll have some things that will be helpful. So what we have here is a set of 4 series. This is a set of 200. These lights are sold in, and this set, for example, it's got one entire unit out here. So there's 4 sets of 50 in this set of 200. One set there, one set here, one set here, and one set here. And there's 50 bulbs in each series. And then these series are connected in parallel, so they're all getting 120 volts. A few basics. In the US, 120 volts is being supplied by the power company at the outlet. When these bulbs are hooked in series, each bulb must carry its share of the 120 volts. Therefore, if there are 50 in a set, 120 divided by 50 means that each bulb is getting about 2.4 volts. You can't buy 2.4 volts volt bulbs, but you can buy 2.5 volt bulbs. Those are common, and that's the most common size of bulb for these types of lights. It is most important to have the right voltage bulb for replacement in these kinds of sets. There are also sets that were made for many years that were 35 lights per set, 35 to 40. And those sets use a different voltage bulb. They use about 3.5 volt bulbs, which are sold commonly. There are also some sets of 40 that have been sold in the past, and we're talking about incandescent lights here, and those would also use about a 3 volt bulb. And you can do the math yourself. Just divide 120 by 50 or divide 120 by 40 or divide by, and you get approximately the correct size voltage bulb that you will need. Another good way is to check on the stinking plug-in here. Sometimes there's a sticker on here, and the sticker actually will tell you what voltage bulbs are used in your set, so you don't have to worry about it. Another way, if you don't have the sticker, or it's damaged or missing, you can count the number of bulbs in a series. So, how do you count the number of bulbs in a series? You can start from the beginning set and work your way through. How do you know when you've completed the series? If you take this set here and take a look at it, the first holder here for the first bulb has 3 wires going into it. It's a threefer. All the other bulbs have only 2 wires going into it. 1 wire in, 1 wire out, carrying the current. On this first bulb here, 2 wires go up, one carrying the current through this bulb and down the line. The other wire carries the current to the next series. It carries full voltage to the next series. So that is hooked up in parallel, whereas this group is hooked up in series. So then each set in turn carries the voltage down, so each set in turn gets a full 120 volts to work with. So that's how they do that. You know the end of the series comes not only when you've counted out a certain number of bulbs, but when you come into another bulb that is a threefer. The holder is a threefer. I don't have these marked. But here we are. So there will be 50 bulbs up to here, up to this threefer. And then lo and behold, right next to this threefer is another threefer. You see it? There's 3 wires going in this one and 3 wires going in this one. All the rest of mostly the rest of these have 2 wires. 1 in and 1 out. 1 to carry the current in, 1 to carry the current along the line. So what happens here is the feed comes in along this line to light this bulb, but another feed comes in to continue the current down the line. So this one comes out and goes directly to this socket, So this socket is fed with a straight 120 volts, which it has to divide up among all these bulbs in this series. With that bit of information, I can now proceed to troubleshoot each section and replace bulbs. When I first started, this whole section had like six burned out bulbs, which I've been replacing. So to replace the bulbs, a good way to get them out is with a tool like this, and you just get under the ridge of the holder there and pry it out. You can't pull these bulbs out, but if they're spent bulbs, it really doesn't matter. You can grab a hold of them. If you can grab a hold and pull on the bulb and the holder and get it out, that's better. If you pull just on the bulb, sometimes the wires will break off and you'll just have the bulb. And you have to get this out anyway. So a tool like this is good. A troubleshooting device like this has got an outfit on here for getting that out. You can also take it out with a razor knife. So once you get the bulb out, all you do is, well, I can check it. I can check it first on this gun, on this test gun, and I want to verify that it is indeed a faulty bulb and not a faulty socket. So I can see that that bulb is out. I'm going to take these little prongs off. Now you can try and buy bulbs with the same holder. Good luck with that. Most of the bulbs are sold like this. They're sold without a holder. And there's basically two structures to bulbs to get. There's the rounded base, and then there's a pinched base, a tapered base. So if you have bulbs in your set with the rounded base, you want to get new bulbs with the rounded base. A good way to replace bulbs is to salvage them from an old set. Most people don't do that. It's too time consuming. I don't think it is too time consuming, but that's just me. Anyway, once you get the bulb out, take a replacement bulb, and I got some replacement bulbs that are salvaged from another set. They all have different bases, and I bought these over many years, and I've yet to buy another set that had the same base. So I kind of give up on that. But when you put these in, make sure they're not crossed. Make sure they're not touching each other, otherwise that'll be a direct short. And if you can kind of straighten them out, I don't think you can see that very well, but just feed them in to the base, and then bend the ends over, so they go right in the sockets where they were. And these copper wire is usually pretty resilient. It lasts a long time. And then once you get it on there, I'm going to test it. Make certain that this is a good bulb. I can test it in here, and I get a flicker from it, so I know that's a good bulb. You see it? And I'm going to set this one in here now. Notice that when I pull a bulb, the whole unit goes out, and that's because the continuity has been broken here. And now that's it. So I proceed to replace all the bulbs in here, and by the way, the more bulbs that are burned out, the greater the load on all the other bulbs. So if you have 2 out, that's okay, 3, not too bad, but when you get 5 bulbs burned out in one series, the other bulbs are carrying too much voltage, and that's going to shorten their life greatly. So if you have a set that's entirely burnt out, that's probably the reason, is that too many bulbs burned out and now the rest of it has failed. And here's another thing. For many years, these types of lights were manufactured without shunts. When they were manufactured that way, when one bulb burned out, the entire unit was dead. They added a shunt, and what that is a little strip of metal at the base of the bulb that carries the current if the filament burns out. So in an old-fashioned bulb, when the filament's out, it's not carrying the current anymore. But in a bulb with a shunt, it continues to carry the current, so you can have 1 burned out bulb, 2 burned out bulbs, 3 or 4 or 5, and it still continues to light the others. So that's got an advantage and a disadvantage. Now, if you get a set where they're all out, There's a couple of reasons for that. Either the power isn't getting to them, or there's some mechanical problem that you should always look for, like a wire severed would be a mechanical problem, a bulb loose or a bulb missing would be a mechanical problem, and those are easy to spot visually. But if you don't have anything like that, if you don't have any mechanical problems, another mechanical problem might be a burned out shunt. So even though the bulbs are all intact, the wiring is all good, there may be a burned out shunt in here that's preventing the rest of the bulbs from burning. And these guns, this new test gun has a provision in it, and you can go to the beginning of the unit, beginning of the series, which is right here, and you can pull the bulb and you can stick the entire circuit into this fitting on the gun here. You see it? Stick it right into this fitting on the test gun. What is the name of this test gun anyway? This is the Light Keeper Pro. Yeah, you can buy all kinds of test guns like this. This isn't very much. It's like $12, I think, or $16. I stick that in there and pull the trigger. And then if you have a bad shunt, that's what it was. That, you pull the trigger a couple times, 3, 4, 5 times, and if it doesn't get any reaction, then it's something else. But if you have a bad shunt and you use that, it'll correct it. That doesn't, you still have a bulb out there where the shunt is faulty, and it's probably a burned bulb. So what I'm going to do now that I've got this lit, I'll be able to find out where the burned bulbs are, and I'll go through and mark them with tape, a little piece of tape, then I'll go through and replace them all, rather than burn this with too many bulbs out. So now I've replaced all the burned out bulbs in this section 3 here, and a lot of them, there were like, these are the bases from the old spent bulbs, if you can see that. So there was a few of them, but I got everything working now on all 4 of these sections, so this is a good working set. And these are icicle lights, by the way. So what I like about these is that they hang down even in the cold weather. They don't stick out in all directions like some of the newer ones do when they have real thick wiring that can't take the cold. So I hope these troubleshooting tips have been helpful to you. Just to wrap up, a couple of things I should also mention. If you don't have any light at all on your unit, completely dead, be sure you have power coming in on your extension cord, and be sure you have power coming in on your input socket here. You can test on the back of the socket with a table lamp or something simple like that. You also test on the final socket if it has one. Make certain that power is going all the way through the unit. So if you don't have that, there are fuses in this unit here, and a lot of the other videos show how to change those fuses. But if you don't have any power at this end, chances are the fuses are blown here. In any case, that's about all we have for right now. This only applies to incandescent lighting, as I said before. Video with regard to LED lighting, light emitting diodes, will be done at another time. So in the meantime, happy troubleshooting and have a Merry Christmas.